David. I get a lot of questions in my videos about power, and I've realised what I need to do is to give my view of the very basics of making power with an internal combustion engine, because it'll give a context to any answers I might give, and also it may be helpful to some of you guys to focus you in on the right questions to ask. Now, before I start, there is two different sides. The first stage is the theory, and that's what I'm going to talk about. The second phase is the implementation of that theory, and that's, for example, should I fit this exhaust or that exhaust? That's implementation. How much fuel should I add? That's implementation. The theory is, how do you make power? What are the factors that affect making power? Once you've got those locked in, you can decide, I want to make more power. This is the thing that is blocking me. So how do I remove it? With an internal combustion engine, and it doesn't matter whether it's a 2-stroke, whether it's a 4-stroke, what fuel you're using, is it diesel, are you using petrol, gas, alcohol, methanol, it doesn't matter. It doesn't matter if you're using a forced air injection system, if you're supercharging it, if you're turbocharging it. It doesn't matter if you're using a carburetor or fuel injection. Those are all implementation at some level. The theory is what generates power. So, very simply, what you've got with an internal combustion engine is you've got a cylinder or multiple cylinders, but let's just focus on one cylinder. Inside that cylinder, there's a piston that slides up and down. At various points in its cycle, it will suck air and fuel in and ignite that mixture. And the explosion of that is what drives the piston down. So that's the absolute point that we need to optimize. What we've got is we've got a mixture of fuel and air, or oxygen to be more precise. When that fuel burns, it heats up the gases, all of the gases that are in the combustion chamber, and that heating up expands. That expansion forces the piston down. How much force is generated in pushing that piston down depends on how well the fuel is being burnt at that point in time, and that's largely down to how much oxygen is present in the chamber at the time. The more oxygen that's available, the better the fuel will burn. Ultimately, fuel levels are implementation. The amount of fuel is something that's relatively trivial to adjust. What really determines the power in your engine is airflow. Almost all of the design changes, all of the engineering changes that you make to a bike to achieve more power relate to improvements in airflow. Now, there are things outside of that. There are choices as to how the fuel's introduced and all that sort of thing. There's how much bearing clearance you're leaving when you build the engine, depending on how hot the engines are going to get. There's how big an engine. Do I rebore? Do I overbore? All of those things are big engineering decisions. But the majority of the things reflect airflow. Things like choice of carburetor to some degree, because that does fuel as well, porting of the engine, free flow exhausts, all of these things relate to airflow. Your starting point is to make your existing system as efficient as possible. Now, bear in mind, this is regardless of what your actual intention is. it doesn't matter if your intention is to produce the fastest bike or car that you can get, or you may be looking for the most fuel efficient car or bike so that you can go the furthest on a single gallon, litre, whatever, of fuel. In both cases, what will drive your ability to achieve those goals is to make the engine more efficient. And the way we make the engine more efficient is by improving the airflow. To summarise, we want to pull as much oxygen into the cylinder as we can to enable the maximum amount of fuel to be burnt, to generate the maximum downforce in the cylinder. We want that piston to accelerate down into the cylinder as fast as we can, because that will generate maximum torque within the engine, and that will then translate through the drivetrain out into actual usable power on the road. I hope this has given you so far some indication of why in my videos to date I tend to talk about airflow. We want to get air in there as most efficiently as possible, and then we want to get the air back out as efficiently as possible so that we can draw fresh oxygen in for the next stroke. We come back to the issue that the power generation is having the correct mix of oxygen and fuel. The problem is that the oxygen content in the air varies from time to time and according to various different factors. The lower the oxygen level in the air, the less power you can generate from that configuration, regardless of how much fuel you push in there. Putting too much fuel in there does not generate more power. In fact, very often putting too much fuel in there will reduce the power levels, because then there's not enough oxygen and it doesn't burn properly. Optimal power is when you've got exactly the right mix of oxygen to fuel. The higher up you go in altitude, the lower the levels of oxygen in the air. This is why mountain climbers on Mount Everest have to wear breathing masks, because there's not enough oxygen in the air to survive for any length of time at those altitudes. If you're down in the Mediterranean and you race up the hairpins from sea level up to 4,000 or 5,000 feet up a mountain pass, your engine will lose power all the way up. Same if you're in America and you're racing up Pikes Peak. As you go up, the power levels in your engine will drop off because there's less oxygen in the air. So if you are running a non-fuel injected engine, then as you go up, the oxygen levels decrease, the mix becomes richer and richer as you go up, which doesn't help. If you're running fuel injection, then the ECU is backing off the amount of fuel it's putting into the cylinder to compensate for the fact there's not so much oxygen. So again, your power levels drop off. So a particular tune will depend on what altitude you are at. Now, I'm more or less at sea level. I would have a dyno run at sea level. If you live somewhere higher up, that particular configuration, putting that particular exhaust pipe, even if you've got the same tune, won't necessarily give you the same power. Race teams have different setups for different tracks that they race at. They run different suspension systems depending on what sort of course it's going to be. They will also run completely different engine configurations to compensate for the different conditions. Similarly, heat. If the air is hot, it contains less oxygen, so again, less power. Humidity, the same. The more water that's in the air, the less oxygen it can hold, because some of the oxygen is bound up into the water. So again, the more humid, the less oxygen the air contains, the less power you will get from the same configuration of engine. So if you take your engine and you tune it for maximum power at sea level, somewhere that's relatively cold and very dry, and then you take it to somewhere higher up, humid and hot, your engine will produce much less power, even if it's running the same map. This is why I say it's complicated. But that's the baseline then. The amount of power that you can generate within your engine is initially driven by how well the air can flow into that engine. That air itself can be compromised by the density, in other words, how much oxygen it contains, and that is driven by things like altitude, temperature and humidity. Those will all affect. So on a different day, your bike might actually have different levels of power. So our objective in tuning for power is initially to remove obstructions to airflow. This may mean that your bike will be no longer compliant with emissions regulations. That includes sound, by the way, so in the area where you live. So that's a balance only you can comment on. So to generate more power, what we want to do is we want to make physical changes to the bike which optimize the airflow through there, and that starts from the airbox and flows through to the exhaust. Now you can do things like porting within the engine. That's always possible, but that's a debatable subject in its own right. Is good porting and bad porting? Then you've got to, once you've got the airflow maximized, then you need to optimize the fuel ratio for that airflow. Anyway, that's the basic of generating power, maximizing that explosion in the cylinder by having the right air to fuel ratio, and 90% of that is ensuring that the air is there in the first place. If the air isn't there, you will not be able to generate power no matter what you do to the fuel levels. Okay, thanks for watching, and I will see you guys again soon.